Everybody, thank you for coming to ShowMeCon. Our speaker this morning, Igor, has over 20 years of technical experience in high-tech companies as a software engineer and technical lead. Prior to joining Checkmarx as our senior solutions architect, Igor worked as a technical manager at Myriad, a leading mobile software company, and as a software engineer and product manager at Novera, acquired by Nokia in 2010. Igor is an appreciated speaker at forums such as ISC2 and OWASP. Igor received his BS in computer science and math from Christian Brothers University in Memphis, Tennessee. Please give a warm welcome for Igor.
Thank you, Andy. I currently work as a solutions architect for Checkmarx. We are a static application security vendor. You may have heard from a unhappy customer of ours yesterday. I understand I wasn't here. But the talk today has nothing to do with Checkmarx. So it's all about Node.js. We had to pull a last minute, maybe not so last minute, about 2 weeks ago, had to pull a switch topics of my talk. Apparently our security team decided that they haven't had enough time to do a full disclosure, vulnerabilities that I was going to discuss. And so they asked me not to deliver the original talk. So we're going to talk about Node.js. I'm going to talk about some things that we all should keep in mind while working with Node.js. Anybody here writes applications in Node.js or maybe tests applications that are written in Node.js? Oh? No? No? Okay. One. So it's a fairly popular framework. So we're going to spend a few minutes on overview of what Node.js is, right? We're going to talk about possible, very simple denial of service attacks and the dangers of the JavaScript eval function. Going to talk about the state of crypto in Node.js apps and some of the interesting exploits that and attack vectors that opens up. And also, if time allows, talk about attacks on NoSQL databases like MongoDB through JSON. So far, so good? All right. I think everybody who was hoping for the other talk left, so I can blame them. All right, so Node.js, server-based JavaScript framework, runs in a V8, Google V8 JavaScript engine, has a very interesting architecture designed specifically for web apps. It essentially consists of a single-threaded event loop that handles requests and passes them off to handlers. It's a very responsive architecture unless you start putting content and long-running applications inside your event handler. Not the event handler, but the event loop. So the first thing you learn about Node.js is that delegate everything to event handlers, don't process data inside the event loop. Putting a little bit of a human touch to the architecture. I don't kind of like these pictures. This, I think, works much better. Right? We have an order taker and an event handler. And no matter how many event handlers, actually fulfilling orders you have, still going to be limited by the guy who rings up the register. So this architecture is good for I/O-intensive applications, database lookups, actually things that most web apps do. right? Because you can delegate those long-running apps to the event handlers, keep responsive, keep your event loop responsive. Now, complex business logic that you would want to process right away may not work so well with Node.js. And so what we're going to do is we're going to demo. I know everybody who actually works with Node probably read all of that at some point. We just forgot about it. Usually forget about basic things like that. So we're going to demo a very little code snippet, right? That sums up, calculates the sum of all the numbers from 0 to I, right? And see how that affects Node applications. So demo. Let's see. I need to move this guy. Oops. You know what? I'll switch to duplicate display, right? Because it's kind of difficult for me to do a demo, not seeing the screen. All right, so let's do this. I have this little app running, right? So it calculates the sum of all numbers from 0 to whatever I give it. So 4900 equals 5, right? Returns right away. Oh, oops. It's pretty cool iguana, by the way. From Galapagos Islands, if anybody's interested. Whew. Here you go. Right? So, sum from everything from 1 to 5 is 15. Returns real quick. Can't really even notice. But what if we, have a little bit of a longer calculation, right? So that, hangs the server for a bit. And that wouldn't be so bad, right? You hang your own session, whatever. But unfortunately, since Node is a single-threaded event loop, it also hangs all other sessions that are going to that server. So here's your perfect denial of service. One session affects everybody connecting to the server. And once this one finishes in whatever minute, the other one will finish as well. So, not validating input. Right? So, see that both of them are sort of finished at the same time. Not validating input can have effect not just a single session, but everybody who uses the server. All right. Weak crypto. Remember, Node.js runs inside Google V8 engine. It's the same JavaScript engine that powers Chrome. And so what we did was looked at a section of code that does user authentication. It's an open source project, right? Sort of a competitor to OAuth. Code is a few years old. Maybe they've changed it. But anybody spot a problem with this code? Can you actually read it from? MD5, right? So it's the first thing that comes up. I bet you MD5 is a problem, right? You shouldn't use it for anything cryptographically sensitive, right? So, but I bet they didn't think that was a big problem in this case because, they're not using it to encrypt anything really. They're just generating a temporary password, generates a long hash, gets thrown out in 4 hours whenever the link expires. So they probably thought, okay, MD5 is, pretty safe in this case. But you shouldn't use MD5 in general. So the other problem here is that they use math random, which, as it turns out to be, is not very random at all. All right? So they, going back, they generate a random number, calculate a hash on it, and give you a link to set or reset the password, temporary link, right, with a long hash in it, right? So V8's pseudo-random number generator is actually known to be weak. There's a research going back to 2009, and link is there, so I imagine y'all get a copy of my slides at some point, so you can go read their original research. It relies on these consecutive states. Each feeds into the next to generate a sequence of random numbers. But as Amit Klein's research showed, by knowing 3 consecutive numbers, random numbers, you can predict fourth and, of course, every number after that, right? So you can predict the random number generator output, and therefore you can predict, in our case, the reset password links. So we'll show that in a few minutes. But to recap, given 3 consecutive numbers, you can predict fourth. Now Google knows about the problem, right? The original research was done in 2009, but they don't really consider it a high severity problem. Why? Because in Chrome, where V8 originally was used for, each tab has its own set of states. So all you can do is predict the next number for your own tab, which is not very useful, right? Because who cares what you're doing with your tab? However, in Node.js, all applications running on the server share the same set of states. So me connecting to the server and generating random numbers affects everybody else who connects to the server and generates random numbers. So going back to our source code, right? We need to generate 3 random password resets, right? That will give us 3 MD5 hashed random numbers. We need to reverse them. Reversing MD5, doable. I have a rainbow table that I'm going to use about, slightly over half a terabyte in size. And then we can compute the states and predict what the reset password would be for the next user. So we register 3 fake users, get the hashes, right? It's very fancy animation. I was playing with PowerPoint, sorry. All right. Get clear random numbers and predict future passwords, right? So demo, right? Probably interested in a demo. Now the demo relies on me being able to connect to aforementioned rainbow table, which requires an internet connection. If any of you tried the internet connection at the conference, keep fingers crossed, right? There. So I have this, very super secure website with a big lock on it, right? That's a sure sign of a secure website, right? And so we're going to do user 1. There you go. Got our first hash. Going to go to my private website and decode this hash. I'm going to feed it into the state calculator. I'm going to repeat it twice more. All right, number 2. Come on. Now the question is, did it actually make it to the server? So it's a third one, or did not? Let's see. Seriously? I'm part of a sales team, so I know how that works, right? But yeah, it always happens during the demo. Yeah, maps come up. All right, let's see. User 3. There you go. Maybe. So let's hope this is number 3. If not, we'll have to redo it from the beginning and hope it works. Okay. So we feed 3 numbers. And we do some number crunching. Number crunching is happening on my laptop, so no internet connection is required. And what we're going to do is we're going to get a new random number, number 4. We're going to predict that number. We're going to calculate MD5, and we're going to compare it with what the next user would get. So the attack vector would be to generate these 3 fake users and reset their passwords, right? And then reset the target's password, right? That password reset link would come over email, but we don't need to have access to that email. We can guess what the reset would be. It does take a bit of calculation, so my laptop's actually quite busy. Now, there's obviously some timing involved. You still have to get the 3 consecutive numbers, right? And kind of rely on the fact that the server might not be busy at night and not many reset passwords. And the target might not notice that there's an email came in with a password reset and something like that. But it's a fairly, I think, reasonable attack vector on the website. And since this authentication component is fairly widely used, you might not even know what's inside your application, and rely on a third-party component. Not my day, huh? Oh, okay, here it is. Nope, not my day. All right, we'll see if we can do it at the end of the day. So it timed out trying to get a hash for the predicted number because of the internet connection. Yeah, yikes. All right, let's go back to let's assume that it working, right? No, my other demos don't require internet connection, so we should be all good. All good. Yeah, but think about it, right? You always have to evaluate the context of the random number generation and hashes being used, even if it feels like you're not doing anything cryptographically sensitive, just some temporary word. Think through the use cases. Eval. Eval is a nasty function, right? It's very convenient. Sort of allows you to just evaluate any expression in JavaScript as if it was part of your application, right? But when used in Node, it can not just execute some arbitrary JavaScript in your app, can actually affect others who are running apps on the server. So Node.js is a web server. Quick recap. There's no separate web server that you would get with a traditional app, right? There's no Tomcat, there's no IIS. Everything runs inside the same JavaScript engine. It's very easy to write app to be a web server. But in a traditional web application, IIS runs your app in a sandbox. And so whatever you do with your app doesn't affect other apps on the server. Unfortunately, with Node, poisoning the web server affects everybody, all apps that are running on it. So eval can evaluate the string. Hello? Can evaluate a string. And again, in a traditional Java or .NET app, that doesn't affect other users or other applications. So particularly with Express.js is a very popular framework for writing web apps, Node. Right? Very widely used. And so in the way you work with Express, right, you write these handlers, which are then mapped to URLs, URL requests. Right? So we're gonna have a really simple application here that adds two numbers. And the way it does it, it uses eval to do A plus B. Pretty simple. Right, so we do eval A plus B. So for example, if I do server.com/add A equals 3, B equals 8, I will get 11. Easy. How does this mapping work, right? So Express maintains an ordered list of functions that are supposed to handle certain URLs, right? They call it stack. Probably in the same way that Denny's calls their pancakes a stack of pancakes, even though it's really not a stack, it's just a list. And this stack can actually be accessed by your JavaScript app at runtime through app.router.stack. Right, so for reading and for writing, and this stack actually affects everybody on the system. So here's what we're going to do. We're going to take the original stack, right, which maps add to function 1. We're going to remove it. And we're going to add a different mapping that maps add to our function. Right? Might do something more interesting than just add two numbers. Right? We're going to multiply two numbers. So let's do some demo. So originally, let's see. Here's 11, right? Everything is fine. Right? So using eval function, we're going to do some interesting. Yeah, let's see. Let's copy this one. Let's do it here, different tab. So we're gonna splice the stack, insert something else. You'll see the code in subsequent slide. But we've replaced the original add with a different function. Notice I did it in my tab. If I just go back and I rerun the same URL, and it's not adding, it's multiplying. I want to do this with my bank. So whenever I withdraw money from my account, it actually adds money to my account. Haven't figured out how to do that yet, but just wait. All right, going back. I love demos that don't require internet connection. Right. Okay. SQL injection, or rather SQL injection in quotes, because we're going to talk about NoSQL databases, so there's no traditional SQL involved. One of the more popular NoSQL databases is Mongo, right? Doesn't use traditional table-based structure. You don't use SQL to run queries in there, so just stores documents and objects in JSON format. And since it stores things in JSON format, it actually allows us to search for things in JSON format. So instead of writing select products from table, whatever, where product ID equals 25 or quantity is greater than 25, you do this JSON search. Pretty simple, actually can match in any field. Very easy to use. So what does it mean for application security? And I imagine most of us are familiar with SQL injection, right? Here's your traditional SQL injection. What's wrong with this? What can go wrong if I just put this? I can put something in a query. If it's not properly validated, the structure of this SQL statement can be modified to say something like where username equals username and password equals password, or 1 equals 1, something like that. Right? Traditional, very vanilla SQL injection. So what's the equivalent in for the NoSQL? In the JSON-based database access, you would use something like this, right? You get named from the query, password from the query, and then find username equals name, password equals password. If you find something in your users table, that's good. That's a wrong approach, right? Because, as I mentioned, Mongo does JSON search. So what happens if we say password username greater than A and password greater than A? It'll find some user. Maybe it's going to find us user named admin, and it'll match any password. So instead of just a traditional, right, SQL injection, we have a NoSQL injection that relies on the JSON matching. So typically, folks are, oh, actually, maybe I'll do a demo first. Let's do a demo first. So I have another really secure site here. It's in a bank. All right. Why does everybody pick on banks, huh? I don't know. So if I do something like this, right? Get sorry, wrong, no such user. No. Stop it. Well, actually notice that, yeah, so that does a normal query. So let's say we use admin. Well, that's the actual real password for admin. But I don't have to actually know the password. All I can do is do our greater than sequence, right? It happily logs me in because obviously admin in the sorting order is greater than A, and the password, whatever the password is likely going to be greater than A. I mean, I suppose if you started with a digit, might have to tweak my query a little bit. But the thing is that there's still ways to inject, do SQL injection and bypass security, even though it's not a traditional SQL database. Now, what do people do usually to, let's see. Yeah, that was my password bypass. So what do developers do usually to prevent that? Right, in a traditional SQL database, you would use some sort of a sanitization routine. You validate user input. You do prepared statements. We'll know what to do. NoSQL databases being relatively new, there's some different techniques. So, traditionally, the thing to do is to first find the user, admin, and then compare the password. Not rely on the lookup to compare the password. Now this, however, can lead to a fairly nasty regex denial of service attack, because I can supply something like, let's see, I can supply something like this. And Node being a single-threaded potentially application. Yeah, that will return pretty quickly. But actually, this has nothing to do with single-threaded. Even if you offload it to your database lookup, this regex can take quite a bit of time, and therefore, if you do this multiple times, overload the server quite easily. So, right, going back. just because you're using the latest technologies like Mongo and Node and JSON doesn't mean you have to forget about all the interesting things we learned with the traditional SQL attacks, right? Still have to validate inputs, still have to clean the inputs and pay attention to the time resource-intensive operations. So I kind of ran out of things to demo. I was hoping that my password thing would take me a little bit longer. Now let's see. Maybe it will work now. Let's see. Okay, maybe you can do it quickly. And the internet connection will hold up. Seems to be working fast. Right. So while it's crunching the numbers, any questions, comments on what was presented? Are you going to be more careful with Node.js applications after this? Yes, you have to raise your hands. All right. So what did we learn? All right. Everything. What? Use Node, but use Node.js, but still validate things. So this time it worked. So we have our fourth random number, and we have our hash. So hash is 8C2663, and if I go back to reset the password for the next guy, I get 8C2663. So everything I told you is real, not stage at all. Right? It's all. I think we tend to forget the basics, right? Not to validate inputs, to not to use MD5 or math random, not to put something that potentially can get CPU intensive and things. Tend to concentrate on maybe some sophisticated attacks. In a lot of cases, attacks are pretty simple, and it's easy to forget about the basics. Don't. Anyway, so I had, and again, thanks for sticking around, even though there was a last-minute topic change. Questions? Yes?
How do you protect the stack? And you said you could swap it.
Validate.
And what other things like that you need to worry about?
Yeah, so eval is evil, so don't use it. In general, if you don't have to run some code, dynamically loaded code, it's better really not to. Code that you get from some other sources is dangerous anyway. And so if you do have to do it, validate it.
So really the issue with the random number generator is that it's predictable after like 3 sequences. Could you have took 2 random strings, generated like 2 strings added together type of thing? And
Yeah, that's right. So
more accurate or more complex?
You could do that, of course, and that's one way to protect it. If you're writing this, mechanism yourself. So the issue with Node, actually, and I'll have a separate talk on that, is that there's a lot of modules that get pulled into your application because you decide to use some framework or something, which relies on different modules, which in turn rely on other modules, that you might not even know what happens, right? So in case of that open source code, it's an open source code. And you might be just relying on that module to not even thinking what it does, right? That's the issue. So if you look at the way these modules are loaded, there's a dependency tree, essentially. And so you might know what you're getting at the first level of that tree, but it can go many, many layers deep. And some of the modules that people pull in are literally trivial. I don't really understand why they bother. Instead of, there's a module that's called, I think, isArray. Checks if the object is an array. You should be able to do that yourself, right? You don't need an open source module to do that. But it's buried somewhere, and so you might not even realize that it's part of your app. So I agree. If I were writing user authentication, I might have done something more sophisticated. Yeah.
Are there any RNGs out there that don't rely on external entropy that are any good?
So the Node in later versions they've tried to introduce their own and not use V8s by creating a larger entropy.
Every language, their internal random number generators.
Yep. That's but again, right? You have to come up with some more sophisticated uses of it, right? Yeah. But I guess if somebody, don't rely on it being random. I suppose think that it might be predictable anyway.
So I have seen like salt radiation decay entropy type random number generators that seem pretty good. But
Right, and so I have a friend who's now whose company now sells a card that does quantum computing random number generator. Supposedly, for right now you can't really predict it. But I think in any case, it's the effort that somebody has to use to break it is what matters, right? And in this case, that's pretty simple. Make it more sophisticated. It's maybe more difficult and not worth going after. Besides, social engineering seems to be the way to guess people's passwords, right? Or get into their accounts, and that seems to work much better, regardless of the entropy of your random number generator, because relies on users, and that's probably the weakest link anyway. Yeah, so you could, right? Again, if you know that it's an issue, it sort of becomes easy to code around this particular problem, right? Generate 2 or a random number of random numbers right before you reset it. So you can deal with it. The question is, did you know that it was a problem in the first place, and did you know that your code in your app actually uses something like that?
Is there a way to log issues like that where you could actually see something like this happening?
In
Like actually to write it into the app to give you some sort of indication that something like this is happening?
That's a good question. That somebody's trying to reset it too often. I don't know. Might not be. I mean, if you just do it from I guess random IPs. How would you? Yeah. I don't know.
I think if you script this, it didn't seem like there was a real easy way to even detect that it's happening.
Right. I don't think there's. Yeah. I think it's the easier to write code that doesn't have that vulnerability. Maybe. Again, if you know that you have it. Do go read the original research. It's quite interesting, and it's also quite interesting to read Google's response. Basically, you shouldn't be using it for anything, so we're not going to fix it. Essentially, well, we know it's weak. It's too bad. Right? So, something like that. All right, guys. Thanks. Appreciate it again.